Hello everybody and welcome to the shop. The time has come to do a job that I'm not exactly looking forward to, but I'm also looking forward to having the skill after it's all said and done. The Babbitt on this crosshead to my 15 horsepower Patton Brothers, that Babbitt needed to be replaced. I obviously already melted the Babbitt off. I just set it in a cookie tray, hit it with an oxyacetylene torch. It just melted all the Babbitt off very easily. And then I degreased it. I used some old diesel, a wire brush. I got it very clean. Then I finally finished up with some carburetor cleaner. Got it nice and clean. I also did the same thing on the crosshead slides. Cleaned everything very well. Even the sides over here, I cleaned everything so there's no gook or gunk. It's all nice and clean and dry. And now the first step, firstly keep in mind, let me say, I've never done this. I have no idea what I'm doing. I'm just going off of some suggestions that I've gotten on Smokestack on the oil field section. So I'm going to be teaching and learning at the same time. If you guys have any comments or help or suggestions, please leave a comment down below. But anyway, the first step is to level everything. That'll make measurement easier. And I'm using a combination of a small level and a big level to make sure these ways are perfectly level this way and that way. And of course, measure everything in several places. So right here, the front of the engine's a little high, and measure, like I said, a couple places. Make sure nothing is out of whack, nothing is bent or worn unevenly. Well, with 3 screw jacks I was able to level 4 corners. I got 2 in the back over there. You can never have too many of these screw jacks. They're awesome to have and they're really good for situations like this, because a hydraulic jack is no good because it'll sink over time. Even a brand new one, you never know how good the seals are. That screw jack is never ever going to drift. But I got it all pretty much leveled. I was starting to flirt with the accuracy of the level itself because, I would measure it and it would look a little bit off, and then I would, do this with the level, put it back on, and it would be right on. So after remeasuring everything several times, everything is pretty much perfect. So now here's the plan. You see I've installed the piston and the piston rod. I did not put the rings on the piston. And I'm using the piston and piston rod in conjunction with the bore of the cylinder and also the piston rod hole as a way to align this piston rod perfectly in line the direction it needs to go. And when it threads into the crosshead, as a result, it also aligns the crosshead. The only thing that it doesn't do is that it doesn't align the crosshead this way, but that's okay. The weight of the crosshead is pushing down, and of course the piston without rings is maybe sinking a little bit lower than it would normally. And also there's no packing in here, so this can float up and down a little bit. So once again, I've taken my level, and you see I've marked it F for front because if you measure this way versus this way, it measures differently, so I chose one end to be front and everything will be aligned according to this. So I started out by measuring how level the cylinder was. As it turns out, it's not perfectly level in relation to the crosshead slides. It's off by ever so slight an amount. Rather than the bubble being in the middle, one edge of the bubble is touching one line. So it's not a very big difference. When I put the level on the piston rod here, I want the bubble to be in the same position, which means that the axis of this piston rod is concentric with the axis, the center line I should say, of the cylinder. And you can see if I pry up on this, it has some play. So I've determined by playing around with it that the middle of the play is both, firstly, a good place to be because you're not pushed up against one stop or another, but also the middle of the play that it has is right about when the level is at the proper point of levelness. So in order to hold the crosshead in that proper elevation, I made this little screw jack. This will be a nice tool to have for a variety of projects. Just a piece of tubing, welded a plate on top, welded a nut into that, and a fully threaded bolt so I could put it under here and jack the crosshead up and down. Now the last step is to orient this crosshead rotationally. Now the only real reliable datum we have on this component is this wrist pin here. So what I devised, I just found a nice chunk of steel in my steel chunk pile. Both ends have been turned on a lathe many years ago, so they're nice and flat, and I verified that with a set of calipers. I measured it in a couple points. There's some grinding spots here because this has been hit with a hammer, probably to drive an old bearing out or something, so I ground off the high points so it's all nice and flat enough for my purposes. So my level is set on here. Also, I marked the F for front, but I also marked an E for exhaust, so I'll have my level this direction, not the other way, because again, this level measures differently depending on which direction it's pointing, because it's just a cheap level. And as long as you keep things consistent, you'll be all set. So you just set it on here like that. Now your level is parallel to your wrist pin, and you can tap the crosshead one way or the other. I used this nice dead blow hammer and get it nice and perfect. I've been messing around with this, and I had plan A, and I decided against it, and I'll explain it. I asked around on Smokestack and I got some very helpful answers, and what I was going to do, following the Smokestack advice, was to level everything, as I already explained, and then using some sort of measurement method, I was using feeler gauges, measure the distance between, or basically measure that gap. And then once you measure that gap, you can make a little dam around your crosshead, and the height of the dam would be the same as that measurement of that gap. Then once you make that dam, you put your crosshead on the bench, you level everything up, side to side and front to back and everything, preheat it, plug these holes halfway down so the Babbitt doesn't just flow right through, and then pour it in nice and level, and gravity will just level the Babbitt out perfectly flat, and that'll give you a good surface to run on this slide. However, I got two problems with that. The first problem is that this gap changes, that measurement changes. I mean, this is rough cast. Now, the reason I'm spending time telling you how I'm not going to do it is maybe this will work for you, so I'm still going to explain it. Anyway, in my case, if this was a machined surface, I would know it's flat and even, and my measurements all around would be the same, and it would make life a lot easier. However, that is not the case. So that'll make it hard to make a nicely, accurately made dam. Also, leveling this thing on its own is going to be really difficult. The only datum I have for leveling it this way is this wrist pin, and that's sufficient. But how am I supposed to level it this way and that way? As it is now, it's leveled by the piston rod being screwed in and lock nutted or jam nutted, and that keeps it nice and level. The only real machined surface to work off of is this thin little area here. And I said, you know what? The people on Smokestack suggested that I don't pour these bearings in place because it's a big mass of metal, you got to get the preheat right and everything. But you know what? You pour the main bearings in place, you pour the rod bearing in place, that's a big, heavy, cold hunk of cast iron. that you have to preheat. So why can't I do the same with a crosshead slide? So that is what I'm going to do. So now that I've explained how I'm not going to do it, just in the event that maybe you can use it on your engine, maybe this is a nice machined surface, I'm going to take apart what I did already. I'm going to take the piston rod out and take the crosshead off. I'm going to really clean everything. I just cleaned this previously, but now I'm going to clean the sides, the underside of the crosshead slides, get everything really, really nice and clean so I can easily apply damming everywhere. Then I will soot the slide with my acetylene torch, running on just pure acetylene. Put everything back together the way you see it, level everything the way I already did with my little screw jack and using this level and all of my methods, get it perfectly leveled the way it is. Then I'll dam it on the ends, on this side, on the bottom side, and pour Babbitt in through this hole, and it should vent out of this hole and fill up perfectly, be nice and flat. And I think that should work okay. I don't think I'll have a problem with any air pockets being trapped. You don't have to worry about air pockets if you pour from the top, like with the first method, and just let the Babbitt level itself. The other potential problem is that Babbitt will probably seep down that little gap between this surface and the crosshead, but I'll dam that up and I'll just cut and scrape off the Babbitt later. And then to do the top bearing, that'll be a little bit more of a challenge, I think, but it would have been an even larger challenge to measure the gap between this surface and the upper cross slide to make a dam. That would be really tough, especially because this part of the casting is in the way, as you see. So what I'm going to do, I'll put the spacers back on, put some shims in there, clean the hell out of the crosshead slide, the upper slide, soot the bearing surface with acetylene soot, put it down, dam everything, pretty much the same as the bottom, and then pour through the oiler hole. The oiler hole is a little bit small, but I'm just going to open it up with a drill bit because it is 3/8 NPT, but you see it's just neck down there, so I'm just going to open that hole up a little bit. I don't see any harm in that. So that's how I'm going to attack this. Hopefully it works out well. The nice thing about Babbitt is if you screw up, the only thing you've wasted is time. You can reuse the Babbitt infinitely. Okay, here we are, all set up again. You see I put blacking, torch blacking, on the lower guide rails. Again, I just used my acetylene torch, burning pure acetylene, and I gave it a couple coats with the torch. I don't know if that makes any difference, but I gave it 2 or 3 coats of acetylene soot. And then with that done, I placed the crosshead right up front here, and then I threaded the piston rod back in. And then I lifted up the crosshead and pulled it back, and then gently let it down in the middle of the rails, because I didn't want to just drag it back and then scrape through the acetylene soot that I put there. And then with that done, I did the same process as before with leveling it, both this way and this way. Now I put the crosshead right in the middle because I want to pour the upper bearings as well with this in the exact same location. And in order to do that, I'm going to need to pour through the oil holes like I mentioned previously. So I wanted the crosshead right in the middle so it would line up with the oil hole so I could pour it. The last thing that I'm going to need to do is to put damming putty around everything. I'm going to do that right before the pour. I'm not going to do that now. And I'll be also pouring through one of these holes. And just put the putty around all the edges, around the bottom lip there, and make sure it's all dammed up. Preheat, and we should be ready to pour. So that's going to be it for part 1. I'm going to make this a 2-part video. The second part will be damming and then pouring. I bought this ladle from McMaster Car, brand new. I was going to buy an old one off eBay, but the vintage ones are as expensive, if not more expensive, than brand new ones. So of course I added this handle. I made it slide so you could slide it away from the heat so it doesn't burn, then slide it forward so you have insulation and also a nice grip. and then I welded a T-handle on there for easier pouring. This cost $25 from McMaster. I think that was a pretty good deal. So anyway, thanks for watching. Make sure to stay tuned for part 2, which will be coming up shortly. And thanks for watching, and come back for more.